All right, this is Mr. Wyrick, and I'm gonna try to go through the notes for you today real quick. I'm out. My daughter is ill. So here's what's going on. We have y is equal to the square root of x. That is our parent function. It's gonna look like this, okay? Half of a sideways parabola and pretty much only the top half. If you make any change to a, it's gonna change how far away from the x-axis that's gonna go. So 2 square root of x is gonna go bigger. 3/4 the square root of x is gonna go smaller, okay? It's just an expansion. Is it taller? Is it smaller? This is my a value, so that's what it's gonna do is a vertical stretch. If it's bigger than 1, and then a vertical compression if it's between 0 and 1, okay? It's one of those fractional values. Right here, if my a is negative, it's going to flip it, and it's gonna flip it upside down, okay? So if I have a negative a out here, like this -1, it's gonna take my regular graph, it's gonna flip it upside down. The one that's a big time difference here is this b value. Now, with your numbers on your b value, it still does vertical stretch, vertical compression. But where this one is a vertical flip or a reflection across the y-axis, this one, if you have a negative b, is actually going to flip it backwards across the y-axis. We're gonna come back this way because remember, you can't take the square root of a negative without using I, and you can't graph those. So this is kind of important on like what's going on, whether your a value or b value is negative. If you do have a number for the b value, it's also gonna do weird things to your c value, but we'll talk about that again in just a second. And on here, the c value, or I'll probably refer to this one as the h value, is still my horizontal shift. It's gonna move it left and right, and just like before, it does the opposite of what you would expect. So the +2 is gonna move it 2 to the left. The -5 is gonna move it 1, 2, 3, 4, 5 to the right, and then it's back to being that normal half of that parabola there. On this one, this last one, you can call it the d value. I'll probably call it the k value. On this one, this +3, you can see it's outside of where my square root ends, which is why it's going to be really, really important that when you write these, you write them correctly so that you can see what's going on. On this one here, we have this +3. That's going to move it up 1, 2, 3. And then it's going to be the same graph. This -6 is down 1, 2, 3, 4, 5, 6, and it's still going to be that same regular graph, okay? Over here, when it's talking about your square root functions, there's a lot of stuff under here. This is the main part. Set what's underneath your radical equal to 0 and solve. That's the x value of your starting point, and then that k value or d value, whatever you want to call it, is the y value of your starting point. So on these, most of these over here, these first ones, my starting point you can see is here at 0, 0, and it's like a ray. It continues forever in one direction, but it does not go forever in both directions. It stops right here. Remember, this is half of that sideways parabola, so it would come around like this, but that's just a phantom part of our graph. We don't fill that part in. When we do this, my starting point on here, if x minus 4 is equal to 0, I'm going to be over 4. This +1 means I'm going to be up 1. That's my starting point. And then I would probably just go like, think about your perfect squares. So you could put 5 in there because 5 minus 4 would be 1, and you can find the square root of 1. And then you would need to do something like 8, because 8 minus 4 would be 4, and you can do the square root of 4. And then, you know, go a lot bigger so that you can get exact points. This is going to be 5, 4. So 4, 1, this is my starting point. 5 up, 1, 2, 3, 4. So you can see because of the 3, this is going to arc up pretty quick. And then 8 is going to be 8 minus 4 is 4. The square root of that is 2 times 3 is 6 plus 1 is 7. So you can already see by the time we get up to 8, we're slowing down. So this is going to go kind of like this. And there's my graph. It doesn't have to be perfect. It needs to be a pretty good estimate, though. On this one, I don't have my H or C value, whichever one. So my starting point is going to be 0. But then I do have this at a -3. So I'm down here like this, and because this is a -1/2, it's going to go underneath, okay? Again, I'm trying to look at perfect squares, so I'm going to skip straight to 4 because I have to multiply it by a half. Square root of 4 is 2, times a -1/2 is -2, minus 3 would be a -5. So 4, -5, you can see I'm barely making an arc at all compared to the other ones. And then, I don't know if I have another perfect square root. I can go 9. Square root of 9 would be 3 times a -1/2 is a -1/2. So that'd be a -4.5. I feel like I did something wrong there. Anyway, if I go 16, I'm going to be off my chart here a little bit. Square root of 16 would be 4. -1/2 of 4 would be -2. Minus 3 would be -5. Oh, so this should have been -4. That's what I made the mistake in. At 16, we're going to be at -5. So 4, -4. Way out here at 16, we're finally at -5. So you can ignore this one here. That's what I get for not being all the way awake. Okay, so your graph is going to look somewhat like that. The paper today is only going to have 6 problems on it. They're going to be like this. Make your table, pay attention to where those perfect squares are, and we'll try to answer any questions tomorrow.